Okay, hello everyone. Sorry for starting a bit late. I hope we'll catch up. Whoa, I'm so impressed to see so many people here. I thought that vacation has already started, and this is actually the first day. So, great, awesome. Awesome to have you here. So, I'm Kamil Hajduczenia, I'm a partner engineer at Google, and today I'd like to talk a bit about building cloud-native applications, and specifically starting from scratch. This is the most fascinating moment, probably. So what we are going to cover today is basically, we'll try to understand what cloud-native applications are and what is the role of Kubernetes in delivering those cloud-native applications. We'll also build a sample Java-based web application that is designed for reliability, for scale, and be able to run anywhere. And I'm going to share a few lessons learned and best practices that I tried to discover over time, and specifically for running applications in Google Kubernetes Engine. So let's start with the definition of being a cloud-native application. One of the best-known definitions is actually consisting of 10 points describing what cloud-native applications are. They describe to have lightweight containers, to have containers independent of the operating system and the actual runtime environment. Those are very great features, but I would like to abstract a bit from those definitions and try to understand what does really mean to be cloud native. So cloud is about running highly scalable applications, being reliable, and delivering efficient applications, efficient in terms of resources that are actually used. So how does it translate to applications that we build? We build containers because they are not only able to run on Docker or simply on Kubernetes, but they are so scalable and so reliable to run on almost any environment. Very recently, there was a new service announced on Google Cloud, which is called Cloud Run. And this is actually a very good example of how cloud-native application might be run almost anywhere. In beneath, there is actually a Kubernetes cluster that is usually running those applications, but this is a managed service. So we don't really care what the actual resources behind this workload are. We only rely on having that application being able to run anywhere and run in scale. So cloud-native applications development today is about building plenty of containers, running those microservices in sometimes a really messy mesh. And this can create a lot of complexity for our environment. So we started with running containers. We started grouping them, and we moved to defining core resources of Kubernetes, like pods, like persistent volumes, like services, and we also continued to build around them. So this is how deployments were created at first, replica sets, and further stateful sets for running stateful workloads, and daemon sets for running applications in multiple instances, one in each node. But then we are still confused. This confusion is built around having resources that are tightly coupled together. This is one of the definitions of having a microservice environment. But this is actually hard to manage sometimes. So we need ways to actually optimize our management capabilities of those workloads. And one of the examples of how this management system could be simplified is having an application resource. So very recently, about a year ago, there was a custom resource definition created called application CRD. And this definition was created to actually group multiple entities, multiple types of workloads that can run together to form a single application. Let's imagine a service mesh that is building our environment around microservices, but having any sense only running together. And grouping them together with all the config maps, with all the secrets, all the services, allows us to actually simplify the management process. This is an idea that is very close to Helm charts, and actually Helm charts can utilize application CRD to create resources that are highly described in your Kubernetes environment and allow you to visualize dependencies between resources, see an overall status of different resources running together. And today we will see examples of those applications. There is also GCP Marketplace, which I have to actually advertise today, because this is something I'm particularly proud of. Being a partner engineer at Google actually means that I work with tech partners of Google to help them bring their awesome products to GCP. And Kubernetes Marketplace, that is part of this Google Cloud platform ecosystem, is actually a great example of how those applications can be managed in a simplified way, more optimized for saving time, saving money, and popularizing correctly built configurations. So if you'd like to take a look, just open Kubernetes apps in GCP Marketplace, and you could see examples of those newly built applications. And today we'll also try to take a look at Anthos. Anthos is a very popular word nowadays, in today's world. It was announced very recently. You might have heard about it. So basically, Anthos is a way of running Kubernetes clusters managed by Google, but operating in your local data centers. This is designed for enterprises, but I will show examples how Anthos configuration can be used in real world. And those are some of the examples of Kubernetes applications that are available on the marketplace. And in the second part, we will try to build an application that will show some of those capabilities. So just to start, could you please, I will just maybe enlighten the screen a bit, just to see you people. I would like to understand how many of you are software developers. Could you please raise your hand? Okay, most of you, I think. And who of you are system administrators? No, this is a blank slide. I think it's on purpose. So, technology. So, who of you are system administrators or kind of DevOps people? Oh, very few. I see. Okay, awesome. I hope you will have a chance to see something new today. So this is probably a kind of a dialogue that you could actually experience in your real life. So let's imagine there is a business person coming to you and saying they need a metrics collection system for the entire marketing team. And that's so obvious. We'll use Kubernetes. Kubernetes is so innovative right now, and we'll orchestrate our application resources using Kubernetes. And of course, regular requirements to handle usage and traffic spikes gracefully, not to lose data, to have reliable system. This is very common. And then what we could do to achieve one of those requirements is actually to separate the front-end layer from the back-end layer, connect them through a scalable transport system like a message broker, and have them scalable independently. So security is a top priority, like almost in every company, in every enterprise. So what we could do, we could run Istio to manage the network traffic.
Not showing any slides.
Oh, sorry. Now we have some technical difficulties. Okay. So how many of you have heard a similar story, like people from business coming to you in the very last minute and expecting to build something useful, and of course running accordingly to requirements in almost no time? Could you please raise your hand? Oh, not so many. Okay, I thought it is more common. It used to happen to me almost all the time. How are we doing? Yes, yes, so we are trying to... Okay. Okay, so I think we are not able to see the screen yet. So in the meantime, what we could talk about is maybe try to understand how many of you build RESTful services, and do you actually use gRPC for that? Is there anyone who used gRPC? Oh, interesting. I thought that this is becoming more and more popular. So actually, in this application sample, if we could see the screen, we would see a nice diagram, or at least a set of requirements. But basically, in the meantime, gRPC is a very popular transport system right now. It is based on HTTP2, and you could optimize your front-end layer, your APIs, with gRPC by reducing the size of messages that are sent. It is usually a lot faster. Just a nice thing to remember whenever you build new APIs. So probably next time I will be presenting this example, I will show gRPC. So what we were talking about is to separate front-end and back-end from each other. So we'll probably have a REST API to enable external systems to connect to our application. We wanted to have Kubernetes as the orchestration layer. We wanted to be scalable, so we want to scale up and down those layers independently. And for adding additional security to our ecosystem, we wanted to add Istio. So this is what we end up. We have a client connecting to a REST API. So of course, we'll have a deployment that is running this API. There is a nice thing called horizontal pod autoscaler. Horizontal pod autoscaler allows us to monitor the resources usage or the load of a particular workload in Kubernetes and scale up the number of replicas hidden behind this replica set deployment in this particular case dynamically. Then we will have a backend. Backend is connected to the API layer through RabbitMQ. And then we'll have, of course, Postgres for persistence. And of course, we want to configure all of that. We'll use config maps and Istio. So let's not waste any more time and try to switch to demo. So I promised to show some code. I hope it is at least visible, but I'm afraid it might not be. So let me just increase font size. Any more? Readable? OK, great, awesome. So we have two very simple applications. As I promised, the API layer and the backend layer. I'm cheating a bit, of course. I promised to create application from scratch. I'm afraid that I wouldn't be able to do it in so limited time. But I didn't cheat too much. I created very simple applications. Those are built with Spring Boot. Are you familiar with Spring Boot? Who is? Could you please raise a hand? Awesome, almost everyone. G. So I see that we have a really nice fan club of Spring Boot. This is awesome. Nothing very innovative here. Like we have very simple endpoints for the API. One of them is simply allowing us to update the resources usage. So whenever we want to send an update to the metrics, like any more usage against a particular resource, we can use this post resource. On the other hand, we also have a get resource that is going to send an asynchronous message to the pub subtopic to RabbitMQ and be served by the backend component. And in this particular example, we are going to ask for the resource usage over time. So this is our front end. As you can see, completable futures. So we expect here some asynchronous communication. And on the other hand, we have the reports broker controller, which is just connected to the, and once again, sorry, this font increase should be persistent. Yeah, that's actually a good point, and their presentation mode. then I lose my navigation a bit, so I might get lost over time. I hope I will not. OK. I hope I remember the names. So here we are just listening to messages that are incoming and react appropriately, like we update the resources usage, or we prepare a usage report and send it out. So this is not that very complicated. On the other hand, we have a very nice Dockerfile, actually even two. Those are very simple. We just use Gradle builds. We use Alpine as the base operating system, as a base image for our builds. This is very well aligned with the goal to have lightweight images, and those lightweight images should be able to actually spin up new instances, new replicas very fast. This is a very important thing. One of the others is that Alpine is usually less involved in any vulnerabilities that are always present in Debian releases. So Alpine is a very nice option to run containers. So in here, we just run Gradle to create a jar and add this jar to our image. The same happens with the API. And now there is something more interesting. I am using Cloud Build. Cloud Build is actually one of the managed services for building CI/CD pipelines in Google Cloud. Cloud Build is actually allowing us to run multiple steps, actually multiple Docker containers being run one by one or asynchronously between each other. Like we can have dependency graph that will allow us to catch any prerequisites for the next steps to be finished before the next one starts. So in this particular example, in this Cloud Build, I'm running a very simple build. Whenever there is going to be a new tag pushed to the repository, I want this code to be rebuilt to create new container images and to put them into our repository. This is one of the patterns that I think is very important for cloud-native applications. In cloud-native applications, we want to effectively manage our environment. And it actually means that we don't want to run almost any manual operations. I think the ideal situation is when we don't run any manual operations. So actually, whenever we are decided that the code has passed the code review, is accepted either as a new tag to the repository or a new commit against the main branch, like let's imagine it is master, it doesn't have to be. But we want to trigger automated operations to deliver an update. In this particular example, I could easily extend this configuration to actually run an update with kubectl to deploy our images automatically to the Kubernetes cluster. But this is something that I wanted to handle manually. So let's just take a quick look at this configuration at Google Cloud Console. So I will just open up this example Cloud Build configuration. And here, I just have two triggers. One of them is the API trigger, which is just listening for any new tags being pushed to the repository. And whenever there are any new tags matching this pattern, starting with V, I wanted to actually trigger appropriate Cloud Build configuration that I showed before. Exactly the same happens for the second application. And this is something that we'll try in real life. And by the way, if you haven't seen that before, there is also a nice thing called source repositories on Google Cloud. So actually, whenever you want to create a private Git repository and manage permissions granularly, just to share them with appropriate people and protect your resources from getting published somewhere, you can actually host your code on Google Cloud. So this is a very nice option. I always love to use it. So let's come back to this Kubernetes Engine UI for a moment. And here, I will start with the list of applications. So in this particular example, I have already created a very initial environment for running our application. I deployed Postgres and RabbitMQ against this Kubernetes cluster. I also deployed this Kubernetes application. And at this point, I wanted to show you this application CRD resource. And I will even open up the source file at first. Just application YAML. This is what I was looking for. So as I mentioned, this is a custom resource definition. This is not part of the Kubernetes API standard yet. So it means that you actually need to deploy this controller against your Kubernetes cluster. But once you do that, instead of managing two different deployments independently, so not being connected in any visible way in our environment, you can actually define a top-level resource that will abstract somehow the idea of our environment. So in this particular example, I decided to have 3 of them created, one for RabbitMQ, one for Postgres, and one for our nice 2 applications. As you can see, I could even use an icon for visualizing our application. This is actually encoded in base 64. So this is a nice feature added. But the nice thing that I wanted to show is that this API and backend component are visible together. So as they deliver the same functionality, they can be presented together. I can easily check the status of all the resources that are forming my environment in a single screen. And this is one of the nice features of this application CRD, that it allows for that. But there are more to come, like managed upgrades that will allow us to automatically update this configuration, these versions of images that are running behind of this application in a just single comment, even from the UI. But this is just coming a bit later. And in this particular example, I could easily imagine that I have a microservice environment that will group like tens of different resources in the same screen, delivering useful instructions, a group of links, for instance, to multiple tools that I use to orchestrate my environment. If I wanted to open a dashboard visualizing the status of my service mesh, that could be linked here from the right side documentation. Next steps is actually something that you can easily manage here from the application CRD resource. And as you can see, it matches whatever was presented here. So a great example of how you could simplify your life being a DevOps person. Unfortunately, we don't have too many here. But even for developers, I believe this is useful to understand what is happening with your application. What's next here? I wanted to mention to you what nice options could you use whenever you are creating a new cluster. And I believe it will show up in among different managed services that are available across different clouds. I think GKE is currently the most advanced, but others will probably follow. So as you can see here, whenever you're creating a new cluster, a new GKE cluster, maybe I'll just enlarge it a bit. You can at first decide to create a zonal or regional cluster. As we wanted to have reliable application, we would probably benefit from running a regional cluster. It means that in case of any outage on a single zone, our nodes will be automatically recreated or even run at the same time in another zone, and the cluster will handle this outage gracefully. Our application will not fail. Another example of configurations that you might want to use for your production resources is actually create multiple node pools. So as you create different resources, you can usually define your resource requests, and it means that the scheduler, pod scheduler, will find the best nodes to run the application, run this particular workload on a particular node. And if you have a single application, let's say, that is highly highly demanding in terms of resources usage, you can easily create one node pool for running those large pods, and then another node pool for running another set of applications with different requirements, for instance, with included GPUs, so graphical processing units. Another example that you might take benefit from is using this VPC native mode. In VPC native mode, your pods will get IP addresses from the same VPC network, so you'll be able to create firewall rules to manage the traffic. This is one more way to actually manage your resources. Then private cluster is also about limiting the traffic only to internal networks. No traffic outside of your network will happen inside this cluster. Network policies. This is something that you could use as an alternative actually to Istio, but just a subset of its features. If you want to manage which resources are allowed to contact any other services or any other pods, this is something that you'd like to probably use. Stack driver integration. This is for having metrics and logs collection automatically enabled. This is one more very nice feature to be used. And here the add-ons, and from the add-ons, I would like to especially mention an ability to deploy Istio automatically to your Kubernetes cluster. Who has used Istio before? Could you please raise a hand? Oh, not very many people. So that's probably useful to mention what Istio is, and we will do that in a few moments. And another nice feature that is currently in beta and will be part of the kind of a premium offering very soon is node auto-provisioning. In this particular example, it helps you a lot with managing auto-scalable resources. Whenever you are creating an auto-scalable application, you need to remember that you always meet the limits of your Kubernetes cluster. So it doesn't really matter that you create a highly scalable deployment if you run it on a very small cluster with a constant number of nodes and with some small number of CPUs and not too much memory. So what you would like to probably achieve is to create additional nodes in your cluster accordingly to the demand. So actually, whenever your workloads are needing more resources, you can automatically let GKE create additional nodes. And this is a very nice feature for production-ready clusters. In the meantime, we have this application deployed and running. So let's take a quick look at what is possible with this application. Is it actually running? So here I have a link. We could use it to access the application. And let's see. OK, this is a Swagger UI. OK, usually loading the list of APIs after a few tries after the first deployment. And as you can see, we have those two endpoints. So let's try them out. I think I remember what data I have put in this cluster. So just to understand if this application is working, we can try it out. Yes, it works. Here we got some resources usage. And these are the parameters that I sent. Oh, oops, there is change me, so we'll need to change something in this application. But in the meantime, let's check if it actually works. So we will report some additional usage. Let's say on the 13th of January at 10 a.m., I want to report additional usage of 200.5 of something. This is a very simple API, so we'll not define more complex information about this metric. OK, it was 200, so let's try it out. Yes, OK, total usage has increased, exactly by the number that we defined. So what we want to do now, as we found this information about overview saying that it needs to be changed, we'll actually try to change it. So now there is this broker, I think, application that defines the static code. OK, so if it says to be changed, Then let's say we have changed it. Okay, now we might take advantage of the CLI and take a look at the status. Okay, one of the changes that we can see here is this application. So let's take a look at what changes were actually made. Yes, it matches, so git add Java, git commit and changed. And now let's tag it. Of course, I am lazy as almost any developer, so I will just increase the version number from 15 to 16. 15 is what we are currently running. Let's just take a quick look at that and confirm if this is true. So let's open the API, let's say, at first. And here in the YAML definition, I think we can see that this is version 15 being run currently, so version 16 will be the new one. And now maybe we'll push the tags. And Devoxx is my remote name. Awesome. What we expect now to happen is actually trigger a new cloud build run. So let's see if it actually happened. Yes, it happened. So we have 2 new builds that were triggered automatically just by the push of code. So it will take a while to build those 2 images, but it will be very fast, I believe. And in the meantime, Istio. So you haven't used Istio, but have you heard about Istio before? Okay, not too many people. So Istio is actually a tool that is built of many different functionalities. It is built to control the network traffic inside your service mesh, inside the Kubernetes cluster. In the most simple words, this is actually creating additional containers, sidecars, to each pod that we want to have this sidecar attached. Basically, we usually define an additional label on the namespace to automatically inject those sidecars to any newly created pod. And this sidecar is responsible for catching all the network traffic that is incoming or outcoming from this particular pod. What it allows us to do is to, at first, control which connections inside this cluster are allowed and which are not. So we can build our own policies for controlling which pods can actually access specific resources, specific services usually in Kubernetes cluster. But not only that, sometimes applications have hard-coded IP addresses. Sometimes they are internal, sometimes external. So Istio by default blocks any connections to IP addresses. You need to define an external service that will match with this external IP address to allow for those connections. But this is not all. Istio allows us also to So at first we started by controlling the network traffic. Then we continued with adding additional security because we are actually able to define what traffic routes are allowed and which are not. Then in addition to that, we can actually measure the traffic, so we can measure how many requests are sent over the mesh. We can also monitor the statuses of it. So this is a great advantage that you can actually measure whatever is happening inside your mesh. And one more thing, because we are routing all the traffic, we can actually discover what is the service mesh visualization. So those four main features are usually very useful for managing a production environment. And in the meantime, while I was talking about Istio, I can see that Cloud Build has finished building and publishing my new image versions. And that's awesome. The last step was actually to push new versions of images to my GCR repository. GCR, Google Container Registry, is one more managed service offered on Google Cloud that allows for storing container images. So now what I wanted to do is to apply the changes, actually run rolling updates of our configurations against the services that we have. So here, in this particular example, I have my Kubernetes app. There is API and as one of deployments, and the second one is the backend. There is a feature called rolling update. Rolling update is a way of running updates to the image versions in an environment that consists of more than one replica of the workload. So it works a bit differently, probably in deployments and stateful sets, but the basic idea is to run updates one by one. So actually, each pod can get a new version of a new definition, actually pointing to a new image version, and in the meantime, we can of course run multiple versions of application, but we can also see what is the status of this rolling update. If it is failing, it will stop. So version 16 is the new version of our application. We will run it on both the API and the backend. So it will recreate the pods here, and the second deployment of the backend. Here we will also run the rolling update. And this was version 15. Let's change it to version 16. And here, as you can see, new versions of pods are being spun up. I'm also a software developer. I don't really do a lot of systems administration, but this UI and the features of Kubernetes are really so intuitive to run once you get used to them. That I believe you don't really need to have a lot of systems administration skills to actually start using Kubernetes on your own. And one more interesting tool to be mentioned. Have you heard about Kind, Kubernetes in Docker? Not really, I see. Okay, so this is one more way of running Kubernetes, because the normal way is actually running a cluster built around multiple machines. Previously, it was recommended to run on bare metal machines to have the most advantage of all the resources that were available. In GKE, Kubernetes is run on virtual machines, so you can actually decide what operating system is run on this virtual machine to actually install Kubernetes. But in your local environments, the option that you usually had to choose was Minikube. Minikube was simply running a VM, a single instance node, that was actually a pretty functional Kubernetes cluster with some limited capabilities in terms of defining like public services, ingresses, and so on. But Kind is another option for creating Kubernetes in Docker, is another option for creating Kubernetes clusters in your local environment, or as part of your CI/CD pipelines. You can run multiple nodes of a cluster as Docker containers, and you can easily test scaling. You can test traffic management inside this configuration. So this is a very nice option that you can take a look at if you'd be interested in running Kubernetes in your local environments. And here, as you can see, our update has finished successfully. So we can see actually 2 pods of the backend component running right now, because this was auto-scalable. During the update process, Kubernetes scheduler decided to increase this number of instances. So let's see if our changes are effective right now. So this is the, I think, updated version of the application. So cluster 1 once again, 2.18.01.01, 2.18.12.31, and try it out. Fingers crossed. This is a live demo. Live demos tend to break all the time, like in this case. Okay, let's just refresh and let's give it another try. Maybe the backend component has not connected to the message broker yet. 2.18.12.31, and try it out. Yes, it worked, and it's changed. Wow, awesome. So this is the configuration that was automatically applied to my environment. This is Istio. Those are Istio features that I wanted to mention, but I also wanted to show you a visualization Istio functionality. There is a nice, actually whenever you install Istio, there is plenty of different tools that are configured on your cluster. In the meantime, I would like to port forward Kiali. Kiali is a UI for different operations that can be handled inside Istio. So now I have it port forwarded, so I should have access to it on my local host, 20.0.1. Kiali, I was already authenticated. So as you can see, I can take a closer look at the configuration that I had in my cluster. So I can see the API, the health status of it. Of course, it complains because I haven't added the labels for app and version, which is one of the best practices that I, of course, forgot about. Then I could take a look at services that are currently not discovered for health right now, but they should be. So probably whenever it would present the status correctly, we could take a look at what actual resources are backed up by this particular service. In Istio, we could define applications if we had those app labels. I haven't added them. But as you can see, this is a nice option to visualize whatever is happening in your cluster. One of many, actually, ways to visualize your cluster. Having Prometheus with Grafana is probably another, but then you need to define your own metrics and your own. Actually, you can take advantage of any metrics that are exported automatically of applications, but you would need to define dashboards to visualize this information. So now, just a quick look at Anthos. As I promised before, we don't have that much time, but I wanted to show you this Kubernetes Marketplace that is allowing you to easily install very popular open source, but not only, also commercial applications very easily in a few clicks. So just an example that I used before. I will just switch to a different project for a moment. I'll open up a project where I have configured an Anthos cluster before. And a simple difference that you can see is here. The provider is GKE on-prem. This is a cluster that was created in external data center. This is not running right now on Google Cloud. And you can easily see information that is a lot limited compared to regular visualization of a cluster. If we take a look at the regular cluster created on Google Cloud, on Google Kubernetes Engine right now, it presents plenty of different information. GKE on-prem is a cluster running outside of GCP and managed by Google Kubernetes Engine. But I wanted to show you those applications and an option to easily deploy those from the marketplace. So for example, RabbitMQ cluster, I can configure it, and all the installation can be done against a selected cluster. In this particular project, there is only one. I can either pick an existing namespace or create a new one. RabbitMQ1, let's say it will be Devoxx 1. Then the instance name that will identify my application and installation. I simply click the deploy button. I don't need to care too much about any additional configuration at this point. If I wanted to, I always have access to the source files of this deployment, and I can easily modify them. Here in this screen, I can see the progress. If I'm bored with it, I can actually see the status, the detailed status of my application installation here. Okay, and that would be it. So I think we saw all the elements that we wanted. We had this Java Spring Boot application visualizing our sample microservices mesh. We had those RabbitMQ and Postgres deployed from Marketplace. We had this cloud built integration. And to wrap up, I think whenever you build cloud-native applications, you want to think about being highly scalable and being reliable. Those are the most important things. To achieve that, you need to build lightweight containers without too many dependencies, keeping them stateless as far as possible, and use as much managed services as possible. Of course, not locking you with a particular vendor, and Kubernetes is a great way to achieve that. So I was about to mention that we also have a Google booth here at the conference. I think on the first floor, very close to the registration desk. You can visit us. You can talk with people from Google about technology, about how is work at Google. And you could actually talk about applying for a job. I was about to mention that we hire in Poland for different jobs, and you can actually follow up with us at the booth. Thank you very much.